Hello friends, welcome to my channel Academic Made Easy PC. If you have not subscribed my channel, subscribe it and also click the bell icon. This topic is area of a triangle. In this topic we will be learning how to find the area of a triangle using a determinant. So see, three coordinates will be given: x comma y, x1 comma y1, x2 comma y2, x3 comma y3. These three coordinates will be given and we will be using only the square matrix. So we will be using 1 1 1 over here, so to make it 3 by 3 matrix. So 3 by 3 matrix only can have determinant, so only we are making it 1 1 1 over here, so that we will get 3 by 3 matrix. So triangle formula is half of this determinant, that is x1 y1, x2 y2, x3 y3, 1 1 1 over here. So that's it. This is a very easy formula to find the area of the triangle, and there are some important notes to make in this topic. So now let's see that. So these are the three notes that had to be made. Since area is positive, we always take absolute value of determinant. Determinant value may be negative or positive or even 0. So we will be taking only the positive values. For example, if I have my area of triangle as -2, can I have my area as -2? Not at all. So I will be taking the positive sign of that. Then it will be +2. Okay, so 2 is my absolute value of the determinant. Okay, so next, if area is given, use both positive and negative values of determinant for calculation. So compare with this one first. So what I said, we may get the determinant value in positive as well as negative. Since we are not having the area as negative, we will be taking the absolute value. So even in question, they are saying that even in question we will be getting the absolute value only. So it's better to take both negative as well as positive value of the determinant in order to find the value of x or y. It may depend. When we move on to the questions, you will be clear why I am saying like this. So next note is that the area of the triangle formed by three collinear points is 0. So what is the area of the triangle which is collinear, which has a collinear points? 0. So automatically, even in determinants, it is 0, they are saying. That's it. This topic is over. So the next topic is minors and cofactors. This is one of the important topic. Why? Because this is a basic. You may not get direct question from this topic, but this is the very basic for the important sums in this chapter. So be very clear with the basic concepts first. So first, let's learn about minors and then we'll move on to cofactors. So first, let me give you the example for minors and then we'll start reading out the definition. See, I have given the examples, two examples. The one is 2 by 2 matrix and the other is 3 by 3 matrix, and here directly I have taken the determinant, and here we can have only from 2 by 2 matrix and so on. Okay, we cannot have 1 by 1 matrix. Why? Because first let me teach you this 2 by 2 matrix, then I will teach you. So see here, this minus is represented as Mij. The general form for minus is Mij only. Okay, so now I have to find the minus for each and every element. Each and every element has a minor. Okay, so how will I represent? Mij means minor is a M represents minor, and this I and J represents the position. Okay, so for example, if I take the first position, that is 1 1, minor of this first element means I will be writing this 4. Okay, I will be hiding this one and this one. That is, it is from the first row and first column. So I will be hiding both also. So what is remaining over here? 4. So only I have written 4 over here. So now next, if I move on to M12, so this belongs to the first row and second column. first row and the second column. So I will have 3 as the answer. So now if I move on to 2, 1. So this belongs to the first column, second row. So what is there? 2. Then 1 more. 2, 2 more. No. So this belongs to the second column and second row. What is remaining over there? 1. So for 2 by 2 matrix, it's very easy. We will be just writing the diagonal elements. So 1, 4, 2, 3, 3, 2, 4, 1. That's it. Over. Okay. So now for 2 by 2 matrix, it's over. Now let's see for 3 by 3 matrix. There's a slight change in this. So see, be very, very clear. So M11. Okay, so this M11 means this position now. So this belongs to the first column and also first row. Okay, so what are remaining now? 0, 1, 2, 3. So now we have to take the determinant of it. So we now if we take determinant, then it will be 0, 1, 2, 3. So this now we have to do it in our mind. Okay, we shouldn't do it as such a big sums and all. Okay, so my X method, so 0 into 3 minus 2 into 1, which is minus 2. So therefore the minor for my first position is minus 2. And if I move on to the second position, only 2 minors I will teach you, and more I will teach you in the exercise sums. I will do it for this one, which is 2, 3. Okay, so this belongs to the second row and third column. So what all is remaining? 5, 3, 1, 2. So hide those, so it will be easy. 5, 3, 1, 2. So determinant, no? So I will be using X method. So 10 minus 3, directly I did 10 minus 3, which is 7. So minor for this will be 7. That's it. So now did you understand? We will be hiding the column and row in which it is present, and then we will be taking the determinant or the element which is remaining. That is what minus. Now I will give you the definition. Minor of an element Aij of the determinant is the determinant obtained by deleting ith row. I said no, that row and jth column in which element Aij lies. Minor of element Aij is denoted by Mij. I said no, we will be leaving out this column and row and we will be writing the remaining. In 2 by 2 matrix, only one element is there. So directly we can write. Whereas in 3 by 3 matrix or determinant, we have 2 rows and 2 columns. So we will be taking the determinant of that. And note for this is, minor of an element of a determinant of order n is determinant of order n minus 1. That's what I said. No, for 3 by 3, no, we will be having 3 rows and 3 columns. For example, if I have to take this element, I will be leaving this row and this column. So I have 4, no, this 4. I have 4 elements I have, so I have to take determinant. No, that only is said over here. Fine. So now let's learn about cofactors. Cofactors is very, very simple if you have clearly understood what is minors. Okay. So there's nothing but, see, cofactors is represented as Aij is equal to minus 1 to the power I plus j. I plus j as the position, okay, ith row and jth column, and into minor of that position. Okay, so now let's see an example to make you all clear. So now we have to find the adjoint of first position, means A1 1 is equal to minus 1 to the power 1 plus 1. I is 1, j is also 1, and what is the minor? 4, no, so therefore 4. So now we will be finding the cofactor form A1 2. So minus 1 power 1 plus 2 into what is the minor for A1 2? 3. So therefore, I will have minus 3. So since it is odd, I will have minus 3. So similarly, you will be doing for other positions also. And now we have to find the cofactor for this matrix B, which is of the order 3 by 3. So now first we have to find the minor for this. So M11 is equal to, so hereafter we will be doing it in such a way only. So for adjoint, everything for the upcoming topics also we will be doing directly. So be used to it. So 0 into 3 is 0, minus 2 into 1 is 2. So minus 2. Okay, so now cofactor for this is minus, it is 1 plus 1 into minus 2, which is minus 2 only. So that's it. It's very, very easy, So, and one more. Let's do here for 8. So, M13 is equal to 2 2s are 4. 4 minus 0 is 4. So, what will be my cofactor? Minus 1 power 1 plus 3 into 4, which is 4. This is even, so 4 is our answer. So similarly, we will be finding for others also. Remark, see, expanding a determinant, there's one more method. See, we will be finding cofactors, isn't it? So with that cofactors also, we can find the determinant value, it seems. Okay, so determinant is equal to the element A11, that element into the cofactor plus that element into cofactor of that element. Okay, so A11, A12, if we are taking in the row, we will be taking like this only. A11, A11. Then A12, then cofactor, then A13 cofactor. If we are taking in column, it will be A11 cofactor, A21 cofactor, A31 cofactor, etc. Fine. So now let's move on to the next interesting topic, that is adjoint of matrix. So this, if you're thorough with cofactors, you can answer this. So if you're thorough with minors, you can do cofactors. If you're thorough with cofactors, you can do adjoint. I said no, this minors and cofactors are not directly asked, but they are asked in a different steps. No, so that's what here. Mostly we will be, not mostly, for all the sums based on adjoint, we will be using cofactors only. So the adjoint of a square matrix A is defined as the transpose of the matrix where Aij, that's the cofactor of the element Aij, it is denoted by adjoint A. So now I'll give you an example. So now this is the example. So now I will teach you how to find the adjoint of A. Okay, so to find adjoint of A, it's very, very easy. So see here, when it is 2 by 2 matrix and all, it is very, very easy. Okay, so for 2 by 2 matrix, what you will do is that, listen very, very carefully. See A11 and A22. See A11 and A22 first. That is a position I'm saying. So these two will be interchanged or swapped. Okay, so if I swap, what will I do? Minus 5 will come to the first position and this will go to 2-2th position. So now you all might ask, what will I do with this? With this, I will do one thing. What is that? I will be changing the signs alone. So my negative will become positive. Positive will become negative. So 3 and minus 4. So this is my answer for adjoint of A for 2 by 2 matrix. That's it. Over. Is there anything tough in this? Nothing, right? Now let's move on to 3 by 3 matrix. So this is interesting one. Okay, more than this 2 by 2 matrix, 3 by 3 matrix adjoint will be very interesting. At the same time, you have to have the full concentration over here. So adjoint of B. Now be very, very clear. So now I'm going to take cofactor for each and every element. I said no, we will not be using a long method to find the cofactors and all. Cofactors is just a step in adjoint of B. So we will be doing directly. So be very, very clear and thorough with cofactors. So I will teach you a method or trick also. So listen here. So leave out this one. So first I'm going to take for this one so leave out this one and consider. So if I take like this, no, I have to cancel out these two rows and columns now. So what is remaining over here? 3, 5, 0, 1. So I have to take the determinant of it. So when I take the determinant, so 3 into 1, that is X method. If I use 3 into 1 is 3. 0 minus 0 into 5 is 0. So 3 minus 0 is 3 itself. So I will write 3 directly. Okay. So now I'm gonna do for the second element. So leave out this and the first row. So if I leave out the first row and the second column, I have 2, 1, minus 2, 5. So now 2 into 1 is 2. Keep that in mind. Minus of minus plus. So 2 into 5 is 10. So 2 plus 10 is 12. Over. So next I will be taking for the third element. So I will be hiding these two. So what will I have remaining? 2, 0, minus 2, 3. No. So 2 zeros are 0. Minus of minus 2 into 3. So plus 2 into 3. Then it means it is 6. So we will be writing 6 over here. So now let's move on to row 2. So now I have this element now, so I will be hiding this and this part. So what will be remaining? Minus 1, 1, 0, 2. So minus 1 into 1 is minus 1, minus 0. So minus 1. Fine. So next I will be moving on to the second element of the second row. So this and the second row will be hidden. So these 5 and 2 will be hidden. So 1, 1, minus 2, 2. So using that X method, when you see like this, your column and row should be invisible. So the remaining elements alone you should take. Okay. So 1 into 1 is 1. Minus of minus 2 into 2, that is plus 4. So 1 plus 4 is 5. Next, I will be moving on to this third element of second row. So I will be hiding these two. So what is remaining over there? 1, 0, minus 2, minus 1. So 1, 0 is a 0. Minus of minus 2 into minus 1. So minus 2. Okay, so next, the first element of the last row. So I will be hiding this and these two elements. So what is remaining? Minus 1, 5, 3, 2. So minus 1 into 5 is minus 5. Minus 3 into 2 is 6. So minus 5 minus 6 is minus 11. Next, I will be moving on to this one. So what will be this? 0. 0 here I will hide and these two elements I will hide. So what is remaining? 1, 5, 2, 2. So 1 5s are 5 minus 2 2s are 4, 1. So next I will be moving on to this last element. So this and this will be hidden. So 1, 3, 2, minus 1 is there. So X method, using that I will have 1 3s are 3 minus 2 minus 1 is 2. So 3 plus 2 is 5. The whole transpose of the cofactor of that adjoint B. Okay. And so now I have to change this sign. Do you remember? No, minus 1 to the power 1 I plus j. You remember, no? So here if I take 1, 1, 1, 1, 2, 1, 3. So here it is even position, odd position, even position. I'll give you the general form adjoint of a matrix. See, this is the matrix which is given. So now what is the general form for adjoint is that? So adjoint of A is equal to A11, A22. That is a cofactor, the whole transpose, the cofactor for each and every element and the transpose of it. That's it. Next, Inverse of matrix. This is one of the very interesting topic. So already we have learnt in chapter 3 matrices. In that chapter we have learnt to find the inverse but using an identity matrix. So here directly using adjoint and determinant of a matrix we will be finding. This is a shortcut way to find the inverse of a matrix. So now let's see the formula. Let A is equal to Aij of order n by n. Then the inverse of matrix, that is A inverse, is equal to 1 by determinant of A into adjoint of A. So 1 divided by the determinant, we will be finding on that value into adjoint of the A. So adjoint we will be finding, and there is a condition for this. Determinant of A should not be equal to 0. So if determinant is equal to 0, then we say that inverse doesn't exist. So if it is not equal to 0 only, inverse exists for a matrix. So this topic we will be learning this. This is one of the important topic which we may get even for 6 marks. So now I will be teaching you the very important properties that we will be using for 1 mark questions, 2 mark questions, etc. And mostly for 1 marks or 1 or 2 marks we will be getting sums based on these formulas. So these are the frequently asked questions. Based on these questions, based on these formulas, the questions will be asked. So be very clear and do make a note of it. So some important properties. So first one is A into A inverse is identity matrix. So we already know, no? So A into A inverse is identity matrix. Next, AB the whole inverse is equal to B inverse into A inverse. Then A inverse the whole inverse is equal to A transpose inverse is equal to A inverse transpose. Both also is same, they are saying. A into adjoint A is equal to adjoint A into A is equal to determinant of A into I. Okay, these three are equal, they are saying. And here, adjoint of AB is equal to adjoint of B into adjoint of A. So for inverse and all those, no? So AB means here it will be BA. If RHS is AB and then LHS will be BA. If LHS is AB and RHS will be BA. Next, adjoint of A transpose is equal to adjoint of A in the whole transpose. So adjoint of A inverse is equal to adjoint of A the whole inverse. Then this is the most important formula, and in the year 2019 to 20 in the board exam, in all the 3 sets we had this a question based on this formula. So even in all the revision papers we had a question based on this formula. So this is very important formula. So adjoint of A, that is a determinant of adjoint A, is equal to determinant of A to the power n minus 1. See, adjoint of A, for example, if it is 2 by 2 matrix, then determinant of A to the power 2 minus 1, that is 1. So the determinant will be equal to the adjoint of A. If not, if it is 3 by 3, then adjoint of A determinant is equal to determinant A to the power 3 minus 1. So determinant square. So that is that. Then determinant A into determinant B is equal to determinant A into B. Matrix A into adjoint A determinant is equal to determinant power n. Determinant A power n. So only if adjoint is given, then n minus 1. If A into adjoint A means n alone will be there. And here determinant A inverse is equal to 1 by determinant. So now here determinant A is equal to determinant A transpose, and this is one of the important formula I said no in the beginning of the chapter itself. This one is very, 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 very important. Even we had these type of question in the revision papers and sample papers for the year 2020. So here K a determinant is equal to K power n. So we will be seeing the n, which is the order of that matrix A. So with this, some important properties are over. If we have some more important properties, I will mention it in the exercise videos. Next topic is applications of determinants in matrices. So for solving the equations, we will be using determinants or matrices to find the solution for those equations. So that is what given in applications of determinants and matrices. In class 10, we have already learned what is consistent system, what is inconsistent system, etc. No? How to find the solution, etc. So here in this chapter, we will be using determinants in order to find the solution. And here we may have 2 by 2 or 3 by 3 matrices in order to find the solutions. Okay, so as we found for the equations, that is quadratic equation or linear pairs, we will be finding whether it is consistent or inconsistent. Okay, consistent means it has solutions, one or more solutions it has. Inconsistent means it does not have any solution. That is what consistent and inconsistent system. Solution of system of linear equations using inverse of a matrix. So now consider in a general form I've given. So a1x plus b1y. So these are the 3 equations. So now how will I split this into matrix? You all might ask. Now I'll teach you. So now I'm taking the 3 matrices, that is A, X and B. So A will contain all the coefficient of X, Y and Z. If only X and Y is given, I will be taking X, a coefficient of X and Y alone. So now I have taken the coefficient of X, Y and Z. Okay. So this A contains the coefficient of X, Y and Z, or the coefficient of the given variables. Next, X is equal to this matrix will contain what are the variables Z in the column matrix only. Okay, so here it contains X, Y and Z. Since my equation contains X, Y and Z, I am writing here. If only X and Y is given, then my variables will be X and Y only. And here B will contain the constants, that is these constants which is in my RHS. Now that only will contain in matrix B. So now, how will I find, you all might ask? So, system of equations can be written as Ax is equal to B, or else X is equal to A inverse B. So here we have to find the values of X, Y and Z only. No? So only I have taken this A to my right hand side. So only I had A is over here. If I take it here, it will be divided by B divided by A. So which I wrote it as A inverse B. Fine. So only I have written it like this. So A inverse into B. So this is one of the important formula that you have to know to do a 6 marks sum. If you have any doubts, mention it in the comment box.
Like, comment, share and subscribe.